Hi, everybody, or the 20 people who showed up. Thank you, I appreciate it. It's been a couple of weeks. Good to see everybody again. Thanks for letting me take the week off last week. I went to a conference up in Seattle. It was a good time. This is a conference I go to every year. It rotates between Portland and Seattle, and for me, it's kind of a good way to begin the year, to sort of get with my people, get with my tribe, and talk about a bunch of Agile software development stuff. But I'm back. And we're back too. So I hope you had a good couple of weeks. The agenda for tonight is as follows. So we'll start with Prime Minister's questions, catch up on how things have been going. Lots of chat on Slack and everything, but I want to make sure that we sort of know where we're all at. Then we're going to talk about Project 5. This starts a new phase in the class, so something that's really quite different from the projects that you've seen so far, and I want to make sure that everybody is off to a good start. And so we're going to go into quite a bit of detail tonight. So thank you for showing up. I think you'll find it worth your while. And so we'll spend probably an hour and a half or so diving into all of that, into Project 5. And then we'll do our final pair programming kata, something called lags. So to start us off, how you been? What you been working on? What questions do you have, either about Project 3, 4, or the koans? Yes?
Yeah, how's the grading for the koans?
The grading of the koans it's not really a pass-fail. It's like pretty much everybody gets full credit for it if your koans pass. In the case, usually, what it is that either, a student will do all of their koans and just get full credit, or like, they only get halfway through and I give them sort of half credit. So, yeah.
They're graded on the PSU machine?
They are graded on the PSU machines. And actually I do that grading because it's easy. And so, I run the scripts and basically, everybody's got whatever is 268 gets full credit. What do you think of Project 3? So the pretty printing, working with sorting objects, working with date formatting. What were some of your key takeaways from that? What did you learn? Distant memory by now? Sorry, what? Collections. Yeah, so let's test your attention. So, or actually maybe we'll say it another way. How did you approach sorting? So there was the requirement that the flights be sorted in the pre-printed output. How did you implement sorting? What classes did you use? Where in your program did you do the sorting?
I just inserted the airlines in the order that they were in the text file, and then ran it through a bubble sort and restored it.
Okay.
Collections.sort, you have to implement flight as a comparable.
Comparable, yep. Okay. Did anybody use a sorted set to set there? Yeah, okay. That's probably what I would have done. But yeah, so that's the nice thing about the comparable interface is that there are all these APIs that'll take advantage of that and sort of do this, the actual work of sorting for you. You just need to specify the algorithm by which you sort compare to objects in the compare to method. Cool. What were your experiences using the date format class? How did that work for you?
So I use the more modern Java local date time.
The Java timing, yeah.
It has a way just to fulfill the conditions of the assignment, it has a way to convert back to the old date time.
Mm-hmm.
So I did all the logic was with the local date time. It has its own date formatter.
Yeah.
It's a local date time formatter or something. It's easier to do the other way.
What made it easier?
There was less dealing with so the old date time is literally just a timestamp.
Mm-hmm. The data object, Java yield date, right? Is what you're talking about?
Yeah.
Java yield date, yep.
Yeah. Whereas date time, I don't know, it's friendlier. It was just easier to conceptualize.
Okay.
I don't know. It just looked easier.
Okay, nothing wrong with that. Yeah, no, it's completely appropriate to use those APIs for this. Good. Any other learnings from Project 3 that people want to share? Any questions still remaining about that? Project 4, XML. There have been some questions on it. Thank you for getting an early start. As I said, it's been a very long time since I've put students through that particular assignment, so I don't know anymore if it's easy or hard. What can I tell you about XML parsing, XML formatting, what people's early experience has been using those APIs? It's not due for another week. No one's even thinking about it yet. Fair enough.
With the assignment, what typically is the library that people use to just approach this?
Well, I mean, the one that you have to use the standard APIs, which are the ones included in the JRE. So that's the org XML SAX API, or actually you'll probably use the org W3C DOM APIs. That's probably the DOM APIs are probably the ones that are most approachable. So, as you'll learn in the XML lecture, there is a Java API that represents the XML document as a bunch of objects, right? There are objects that got methods, you can call them and things like that. And what you do is you create an object graph that mirrors the XML document. Then you use these things called transformers to take that object graph and turn it into text. That, the XML text, which is then written out to the file. It's I'll warn you now, it's an old and clunky API. But then again, it works, and it's all actually part of the lesson is to okay, here's some old code, go figure it out. Nice. Yeah. Yes.
We feel like there's XML lecture stuff right now, and before class 5, we're still looking at how does the DTD interact with DOM?
Great. How does DTD interact with DOM? So the DTD, the document type definition, specifies the format, the grammar. For those of you who have taken compilers or right, the whole idea is that the DTD is the grammar that describes then the XML language, the particular the Airline XML language. Actually, I can bring it up here. And by the way, so a couple people have asked about the DTD and there's this URL to it, and then you go and put that URL into the browser, and the browser's like, what the hell is this? This isn't an XML document. It's like, true, it's a DTD, and so it's not rendering it very well. You should be able to find it in IntelliJ if you go and say open, well, actually probably, shoot, where is that? Navigate file. If you then type DTD, it'll bring it up here in the dependency, and you can just open it up. So the whole idea here is that this is a format for specifying the the structure of an airline XML. So there's an airline element that consists of a name and 0 or more flights. A name is something called parsed character data, which is just a string, et cetera, et cetera. And so then if you, this is actually probably good to have side by side. What's airline XML? Oh, here's an example. Airline. So I'm just going to put these side by side. Move right. Okay, get rid of this. So here on the right is what the XML looks like. So there's the airline tag, and underneath that is the name and a bunch of flights. And so it's represented over here in the DTD as an airline that consists of a name and 0 or more flights. So a name is just parsed character data, meaning that inside the name is just a string. And then each flight consists of a number, source, depart, destination, et cetera, et cetera. And so here, as you can see, the flight has a number, a source, a depart. Depart has a date and a time. All this stuff is parsed character data, or rather the source, the number, parsed character data. A date has a bunch of attributes. Date has a bunch of attributes like day, month, year. And that's just, again, strings here in the attributes. So I go into more detail in the lecture, but the whole idea is that the DTD specifies the format and specifies it in a way that an XML parser can validate against it. And so the whole idea, the big takeaway from the assignment is that unlike in projects 2 and 3, where you had text files of your own format. Project 4, we're standardizing the format of the airline representation so that we can then exchange airline information with each other if we were so inclined. And also, I suppose, in Project 4, you don't write the parser. You leverage the third-party XML parser to parse the data. Sure, you need to convert it from like the XML API, the DOM API objects to your own airline objects. But you're not sitting there manipulating files. You're not like counting characters and doing all of that. You're letting the XML parsing libraries and formatting libraries take care of all of that for you. I guess those are probably the two big takeaways from the assignment.
Do you pass the DTD to DOM somehow?
The DTD, yeah, let's look at that, because actually that's an important. I'm really glad you're asking these questions. These are good questions. So there's a class called XML Helper, and it's got a test, which this is something that you all have. I believe it's created as part of the archetype. And I highly recommend that you take some time and study this, because it gives you sort of an idea of where to start with XML parsing. So basically, this has two tests. One that says, hey, listen, I've got a valid XML file, and I've got an invalid one. Can I parse it, and does it get the error that I expect? So really, it's this Airline XML Helper class, which takes care of... Sorry, and where do you use the API? Oh, there it is, the entity resolver. Okay, it's when it comes to finding the DTD, let the XML helper take care of that for you. So you'll learn about let's see, the Airline XML Helper extends this class called Project XML Helper. And what Project XML Helper does is it implements a couple of standard interfaces, one called Error Handler that comes from the SAX API, then one called Entity Resolver, also comes from the SAX API. This is and what these are what are called callback interfaces that interact with the XML parsing library. So the XML parsing library has the knowledge, has the logic for reading XML from some source and going through and parsing it, and doing things with the XML document as it parses it. Now, while it's parsing, it needs to interact with the outside system. So, for instance, let's say it encounters an error while parsing. What should your XML parser do? Should it throw an exception? Should it log the standard out? Should it pop up a dialog box? It doesn't know, right? Because it's all dependent on the application in which it lives in. So what it does is it delegates the responsibility for handling the error off to some other piece of code. This is code that you as the application developer ought to provide so that it handles the error appropriately. The way it communicates this, the way it delivers the error is through something called an error handler. So there's this interface that it provides. It's like, hey, listen, calling code, application code, if you want to handle an error, or rather, when I encounter an error, I will invoke a method like warning on the error handler interface that I'm providing. So what this Project XML Helper gives you, I guess what it is it simply provides an error handler that throws the exception, which maybe is probably what you want to do. But anyway, I provide this. For better or for worse, the default behavior is to do nothing when you encounter one of the XML parser. Here again, it doesn't know what to do, so by default it's no op. That's probably not what you want to do. So what I provide you is a default method, is our default implementation of this error handler that just throws the exception. And so back in your test, you create this XML helper, and then as you're using the standard APIs for parsing XML and creating DOM objects, there is this method called setErrorHandler on this standard document builder class, and that's where you pass it the error handler, which is the XML helper that implements that interface. So that's how the how the XML parsing APIs report errors out. Now, another thing that the XML parsers need to do is to be able to do things like find DTDs, right? So it goes and it's parsing this XML document, and it finds the doc type declaration and says, okay, great, this XML document has a root element of airline. Oh, and by the way, its system, and its document type is described by the thing at this URL. So the XML parser is looking at this XML. It's like, okay, great. I need to go find this thing here. Now it's a URL. It's probably smart to go and download it. However, maybe you don't want to have to go hit the internet every time that you parse an XML file, or maybe you're in some sort of air-gapped environment where you don't have access to the internet, or maybe let's see here. I wonder if I can find an example. I bet valid airline. Oops. Oh. Or you have. Oh, that's got system DTD also. You can also have something called a public ID. It's all in the lecture. Anyway, the whole idea here is that the XML parser needs to go find this DTD. For that, what it's called is it's trying to resolve an entity. So there's something called an entity resolver. An entity resolver that is also provided by the XML helper. And so the entity resolver has a method called resolve entity. And here I've implemented this method for you to basically go and load the DTD from the jar file. So my jar file that has all the project classes also has the DTD included in it, and this will use the Get Resources Stream, which I think a lot of you are familiar with, API to go load that DTD file and then send it to the XML API. So this is taken care of for you. There are certain details of XML parsing that I'm just going to help you out with, like this whole thing about the entity resolver, whole thing about the error handler, because I really want you to focus on using the DOM API and things like that. So step one is to go check out this test and basically use this code whenever you parse the XML. And you'll probably want to use the same error handler when you go and generate the XML, dump the XML also. Good questions. Thank you for asking them. Project 4. Anything else on your mind? Again, it's been a long time since I've had students do this project. I encourage you to start it early. It might be more complicated than you think. I don't know. All right. Anything else before we move on to Project 5? Nope. Okay. Project 5. So, the beginning of this course, we worked with the command line, and we work with the command line in one process. So this is basically the same kind of programs that you've been working with since your first CS course, most likely, right? Your program's execution starts with the beginning of your main method. It does a bunch of stuff, calls other classes, calls functions, system API, all that kind of stuff, and then ends when the main program ends. And this makes a lot of sense. It's easy to explain. It's very comfortable. But it's not the way most software works. Most software, or at least a lot of software, is long-lived, and so you've got like a long-running server process that sits there and handles requests. In Project 5, and then also in Project 6, when we run the Android, when we start writing an Android application, you'll be dealing with long-running programs. Now, in Project 5, you'll still have a command line utility. You'll have multiple programs that talk to each other in Project 5. And I'm just going to warn you now, this is different from what you've been doing. And it's really an order of magnitude more complex. And I think it also makes it more interesting, more challenging, and more fun, but it's different. So what I'm going to do tonight, I'm going to tell you about Project 5, which involves creating a new Maven project because there's some different technologies involved. And then I'm going to show you how to work with the Project 5 archetype, sort of what's there, and what you can do with it. So for Project 5, we're going to continue our Airline application, but now we're going to add the ability to have a RESTful web service. So now you're going to have two parts to your program. Not only are you going to have your command line program, but your command line program, instead of doing the work of creating an airline and adding a flight to it and write to a file or whatever, it's going to interact with a web service, a web server over HTTP. So this gives you an opportunity to work with developing web applications in Java and also learn a bit about how HTTP works. Now, in web applications, there's something called a servlet. So a servlet is an object that's created and sort of hangs around, and its job is to respond to web requests. So someone sends a URL or requests a URL of a web server, and it's your servlet, which is the Java code that then handles that request. It gets information from the request, from the URL, or from the forum post or whatever, and then does something with it and returns some result. This provides something called a REST API, which you can learn about, and actually hopefully you have reviewed in the lecture. And the API is supported by the following URLs. So you'll hit the URL on a host and a port. Oh, by the way, do you know what a port is? What's a port? It is an identifier. I think of it as like this conceptual hole in the back of your computer, right? So right, that's what it is, right? I mean, okay, right? You've basically got all these holes that information can go through and come in from. So you've got your host, which is the name or the IP address, the location of the machine itself, and then it can communicate with the outside world on that address or by that host through different ports. So when you want to communicate with a machine, you've got a machine you've got a program on that machine, a process on that machine, which is sitting there listening on one of these ports, waiting to interact with it. So, and ports are, there are a bunch of standard ports that are assigned to various protocols, right? So port 80 is HTTP, port 443 is HTTPS. So maybe you've seen this in URLs and things like that. There are ones for SMTP, for mail, for well, UDP isn't really a port, but anyway, various protocols have different things. Normally, only privileged processes can run on those lower ports. So what we'll be using is a port like 8080, which is a high port, which doesn't have the same restrictions on it. So anyway, so that's what a host and a port is. So that's part of a URL. So when you go and fetch a URL, you say, here's the host and here's the port that I want you to try to communicate. And then when you hit the /airline/flights URL with a query, a question mark of airline equals name, what that will do is it will return all the flights in the airline formatted using the XML dumper. So when you hit that URL, what's sent back is a bunch of XML. Okay. So, oh, and by the way, and you probably, again, if you watched the lecture, you should know this, but maybe if you didn't, or if it didn't make sense. Something that you might not know about the HTTP protocol is that there are these things called verbs, which are you're basically saying, hey, for this URL, do something with that URL. So get is like, okay, hey, give me the content at that URL. Post is a way of saying, well, here's some information I want you to, here's the URL, here's some information I want to deliver to that URL, please do something with it. Like, I want to create new data. So when you want to create a new flight in the airline, what you do is you add a request parameters. You first of all, you post to that URL and you provide parameters like airline, flight number, source, depart, destination, and arrival. Basically all of what's there in the command line, all the parts of your flight. You give all of that to that URL as request parameters. So that's how you create a new flight via the REST API. There's also some new functionality for your airline that's exposed via the REST API, and that's the ability to query the airline. So if you say, right, so if you then specify the flight's URL with, you give the airline name, and you give the source and destination airports, what that will return is an XML representation of all of the flights in that airline that originate at the source airport and terminate at the destination airport. So not only are you learning about posting to working with URLs and working with web applications, you also need to add some new functionality to your program. There's also a new requirement that the web application must support multiple airlines. So we're up to date when we were, previously when we were working with files, there was one airline per file. Now your web application can support multiple airlines. So that's what's happening on the server side, and all that is exposed via this REST API. We'll see later in class sort of like how this works in code. So that's what's happening on the server side. On the client side now, there's still a command line application that you'll write, but instead of doing things like writing to files, it will interact with the REST API. So there's a Project 5 class that makes HTTP requests to the server. Now, as far as the command line is concerned, it's the same date format as the previous project, so that's AM, PM, not 24-hour. And it looks very much like the command line in previous projects. So it's the same arguments, the airline name and all the information that's required to create a flight. But the options are a little bit different. So now you've got a dash host and a dash port option, which is for specifying the host name and the port through which to, of the REST API through which to communicate. There's also a new option called search, and I'll show what that's about in a minute. And you still have your print, and your dash readme, just the same as the other assignments. Note that both host and port must be specified. There aren't default values there. Let's not make it complicated. And here are some examples of how to work with the command line. So here's how you add a flight to the server. Say dash host, localhost, dash port, whatever your port is running on, and then you have the name of your airline, and then the flight number, the source airport, the departure time, the arrival airport, and or destination airport, and the arrival time. So that looks pretty much like your previous assignments. Here's how to search between two flights. Here you're searching for all flights that originate in Portland and terminate in Los Angeles. And by the way, you say, yep, you need the host and the port to tell it, here's the REST API to access. And you say dash search, and you give it the name of the airline and the source and the destination. So this is different from other assignments. You no longer need to have the rest of the flight information. You just have the originating and terminating airports. And what this will do is it will pretty print all the direct flights. So notice that your API returns XML. On the client side, you need to take that XML, turn it into the pretty output, and then write it out to standard out. Also, you can use the following. So without the search and without the two airport codes, to pretty print all the flights in an airline. So you have this command line program that interacts with your REST API. So with regards to error handling, it's sort of the same kind of stuff that you saw before. It's kind of funny indenting. You should exit gracefully with reasonable error conditions, such as your command line is messed up, your date and time format is not right, you can't connect to the server on the given host and port, or if you pass bad data to a REST URL. I'll tell you right now, there are now multiple entry points into your overall application. Right, the user can interact with your application now in two ways. One is the command line, like they've always been doing, so you've got to do command line checking. But the other one is the REST API. These are URLs that you're exposing, and these URLs can, as we'll see, these URLs can be accessed not only through the command line, but you can hit in a web browser. You can use curl, right? You can access these web APIs in different ways. And so now you need to protect against bad data, not only in your command line, but also in your REST API. So that's the application. There's some new functionality in your from your previous projects. Not only the fact that there's this REST API, but now you need to do searching. Your command line is a little different, but by now you should be really good at parsing the command line. And now you've got to implement all of this stuff in the web service. Yes, question.
So how will we write unit tests for this?
We will see shortly.
Okay.
Because, oh yes, and you better believe that test-driven development is part of this, as is code coverage. So it's different, but it still follows the same sort of principles. So let's start looking at the code. Now, the web application is fundamentally different from your. Oh, sorry, you had another question? Yeah.
I just wondered, so are we going to be actually hosting our data on a web server, or is it just these local XML files?
There will be a web server. Actually, there are no files involved. You don't write files anymore. You're out of the file business, finally. However, you still need to produce XML data.
Or XML's not file?
Nope, XML is XML. It can be anywhere. XML can live in a file, can live in memory, it can live, okay, on a file memory. I don't know, you can print it on a piece of paper, I don't know, right? You know, optical scanning, I don't know. Tattoo it on your, anyway. It's a terrible sequel to Memento, but anyway. Right, so, because remember, XML is just a data format. It's not a file format, it's a data format. And the fact that it's persistent in a file, great, it outlives the execution of the program that created it. Actually, to that point, you're right, your data isn't written to a file anymore. It's persistent in memory, so as long as your web service, as long as your web container is running, the information's there. It's just not in persistent memory. It's not persistent, it's just living in memory. So we'll see how all of this works shortly. That's a very good question, though. Okay, so now the code. Brand new code base to start over with, because now your Maven project doesn't just have the source code for your command line application and the ability to build a jar file and run the unit tests and everything like that, run the integration tests. Now you're writing a web application, and there are more parts to the web application. There's still a lot of Java source code, no problem there. But there's also a lot of configuration. There's not a lot of configuration. There's some configuration that basically says, oh, hey, here's where to map here's what my servlet is. Here's where to map the URL. I'm not going to go into all that detail. You can see it in the lecture, understand a little bit more about it. So it has some different kind of source code and configuration. It also does more with Maven. So let me just take a step back and briefly review what Java Web Applications are all about. So for your command line application, what did you do? Write some source code, use Maven to compile that into a jar file, and then on the command line you type java-jar, and that runs your program. Okay. And what does that do? It starts a Java virtual machine, says, oh, here's the class path with a jar file on it. Here's the main class, and it starts your main method, and it's your main method, and it runs and it exits, and everything's fine. A web application is different. So there's a series of APIs. The servlet API is one of the APIs that Java provides that model a web application. And really, the job of the web application is to provide some response to a URL. So what your logic is ultimately handling a URL in some fashion. But there's a lot of machinery machinery. That's the right word. Yeah, there's a lot of machinery for handling the HTTP request and then ultimately translating it into a call to your servlet, this Java object that you provide that sits there and runs in memory. There's lots of configuration, there's lots of routing, things like that. There's something called a web container that does all that heavy lifting for you. the job of sitting there and listening on the port, right? That has the socket that's sitting there taking data in from these requests and parsing the HTTP data, making sure everything's well formatted, and then taking, yep, we've got a good HTTP request. Then we need to figure out how to route it out to your servlet object and invoke the right methods on your servlet. All of that is taken care of for you in something called the web container. The web container that we're using is something called Jetty. It's a lightweight implementation of all of these standard APIs. So what you do is your code gets bundled into something called a web application, which consists of some configuration information like a web.xml, and then all of your class files from your source code. That gets deployed into your web container, into your Jetty, and now you've got something that you can hit a URL. When you hit a URL, your Java code will be invoked. Maven, for a web application, not only compiles all the Java code and builds the web application, but it can also deploy it to a Jetty, all in one fell swoop. And this is really nice, right? So you don't need to worry about starting things manually yourself and then deploying. Maven takes care of all of this for you. This allows you to focus on writing the code and not so much about the infrastructure that it takes to actually get your web application running so that you can work with it. And so you create a new project. So, and actually I encourage you all to play along at home. So here we are. I'll make the window a little bigger. Yep. Actually, no, I won't. This way the bottom of the screen will still be there. Let's make sure the environment's clean. It is. Okay. So there is a create project 5 script. Just like the create project 1, although it's been a long time since you run it. You run it. So create it and give it your user ID. This will create a new project called Airline-Web. So now get status. Okay, it added a new Airline-Web. So this is the beginning of a new project, a new Maven project. You'll have to take your airline class, your flight class, your XML dumper, pretty printer, other stuff like that from your other project. Just copy it into this source directory. That'll be fine. Now, of course, the first thing that you should do with any Maven project before you make any changes or whatever, make sure everything runs. So let's see here. I will make the Maven W script executable, and I'll run clean verify. So then this will, probably for many of you, download a whole bunch of jar files and stuff, and so this will build the project. It compiles the code, it runs the unit test, it builds the artifact. In this case, it's a web application, something called a WAR file instead of a jar file. Then it runs the integration tests. The integration tests, and I'll go back to this in more detail later. The integration tests actually run the web container and run some tests that actually exercise the REST API sort of running for real. Everything's clean. This is good. Okay, so then I will add all of this stuff to Git. Git add pom.xml and airline web. Lots and lots of files to add. And we'll talk about, well, some if not all of these tonight. Added a added the beginnings of a web application for the airline. Great. Push that up to GitHub, and then Travis will run and make sure everything still functions. Okay. Now I'm going to go back to IntelliJ. I'm going to refresh my view. I'm going to synchronize my environment. That should pick up those changes. Looks like it's doing some analysis. Detected a new Maven project and stuff. I think I have auto import on. So now if I go and I look, it has airline, but now it has airline web. Okay, good. Okay, where to start? Let's talk about what's here. So looking at my source code, I've got a couple of things. I've got a project 5 main. I have something called the airline servlet, and then I've got a airline REST client. Now, the names of these classes are Airline, but what's actually there is a simple little application to let you explore the whole client-server communication. So when I look at this code tonight, what I'm going to see is a simple dictionary application that basically maps, two words together in a word and definition little toy application. So I do this just so that, first of all, I can demonstrate that all the pieces fit together, that you can have a web application that is called by a command line, but it's also intended to give you a place where you can gradually evolve your web application over time using test-driven development. So I'm going to start. I'm going to start on the back end with something called the servlet. So I'm going to get rid of that guy for now. As a matter of fact, I'm going to let's close the other tabs and start here. Okay, that's big enough. So the servlet is the code that handles the HTTP request. So the job of the web container is to take the HTTP request and decode it, and ultimately use that information, send that information to your servlet object by calling its methods. So Airline servlet extends the standard HTTP servlet class, and it has methods for handling HTTP requests of various flavors. So when you perform a get on the URL, it will invoke the doGet method. The doGet method. If you invoke a post, it'll invoke doPost. Similarly, there are other HTTP verbs like delete, and you can do the delete. I have a delete here just for testing purposes. It clears out everything in the dictionary, etc., etc. So that's what the servlet does. That's what the servlet code is. Let's run this code and interact with it. So here on the command line, I'm going to go to my Airline web, my web application here, and I'm going to run something called, I'm going to use Maven to run something called Jetty run. So Jetty is the web container. This is the thing that actually is the web server, if you will, and into that web server is deployed the application, the web application that contains my servlet. By default, it runs on port 8080. This is on localhost. And so now, I guess one more thing. So this is the code that's run. There's some configuration inside a file called web.xml, which basically you shouldn't have to change. But what it does is it says, oh, hey, when you receive when you see the /flights URL, when you see a URL that ends in /flights, please route that to the Airline servlet. So now, if I go to my web browser and I open up localhost 8080 /airline, that's the name of my application, and if I go to the flights URL inside that, that will now hit my servlet, which tells me that my dictionary on the server contains 0 words. So this is that simple web application that we have that basically writes the contents of this dictionary. So that's what happens when you hit the URL.
You're sending a GET request?
Okay, I'm sorry, yes. When you, in a web browser, or actually I can, here, let me do it, let me make this one a little bigger. From a web browser, or actually, do I have which W? Do I have? If I do curl that same URL, I get the same output. So I'm hitting that. I am doing a get of that URL. So I'm saying HTTP get. So either through curl or just loading it in the browser loading the URL in the browser. This makes an HTTP get request to that URL, and that's what it returns. Dictionary on server contains 0 words. To help us understand this code, I'm going to use the debugger. So remember how I said that starting in Project 5, things get a lot more complex? One of the biggest sources of complexity is the fact that you now have two programs running at the same time. You're going to have your command line program running, and you're also going to have your web service running. You're also going to have your web application running. And you're going to have one program talking to another program, but it's all in the same code base. It's all Java, it's all serving the same code base, but now there's two programs. And when things go wrong, did something go wrong in the command line program? Did something go wrong on the server? It's really hard to find out. This is where using a debugger is essential. How many people have used a debugger before? Like GDB or something off from the command line or whatever. Hopefully and how many have used it in an IDE, like a graphical thing? Okay, a couple of you have. Good. I'm telling you right now, you have permission to use the debugger. This is what real software engineers do, right? They use the debugger to help them understand what's going on in the program. So that's what we're going to do now, is use the debugger. In Java, when you what we're going to do is we're going to start up our web server, and we want to be able to debug it. Now, the web server is running in its own process, and IntelliJ, which is the debugger that we're using, is running in its process also. So we got to tell the two processes how to communicate. So what we're going to do is we're going to launch the web server in a special mode that says, okay, hey, I'm launching you in debug mode, and by the way, listen on a given port for a debugger to attach. So I need to tell my Jetty, when I run it, to run in debug mode. And so there's some magical command line arguments that I can never remember off the top of my head. Luckily, IntelliJ makes that pretty easy to figure out. So you might have seen this before when running your unit tests and stuff. IntelliJ has this notion of run debug configurations. So we're going to create a new configuration, which is going to be, I believe it's called remote. Yeah. So this is attaching a debugger to a remote VM, and this is going to be on localhost, and it's going to run on port 5005, which is some default port for debugging. This is telling IntelliJ where to attach to, but we also need to tell the Jetty process, here's which port to run on, or actually run in debug mode, and here's which port. That's this big old command line here, which hopefully you can see there. Or that's right, this big old option right here. They make it really easy to figure out, so I'm just going to copy this to the clipboard. And now in order to tell Jetty to run in debug mode, I need to set an environment variable for Maven. So actually it's Maven that runs in debug mode, and so when Maven launches Jetty, it'll be in debug mode. So you say export, so I'm going to export an environment variable called Maven _ ops for Maven options. I'm going to paste in this thing, this whole -agent lib blah 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 blah, and all of this came from this right here in IntelliJ. So basically, what this is saying is, hey, run the debug agent, if you will, and communicate with the debugger over a socket. Server mode, I can't remember what that means exactly. Suspend equals N for suspend equals no, which means go ahead and start up because the debugger will attach later. We'll see when we run the debugger on the command line, we'll want suspend equals yes, which is basically like don't do anything until the debugger attaches. And then the address, the port that we're running on, well, it's the current host. It's really any host, and it's port 5005. I'm going to run Jetty again. You'll see it scroll by. It says, oh, listen, I'm waiting for someone to attach on port 5005. Now I go back to IntelliJ. I'm going to save this configuration right here as localhost 5005. Now when I click the debug icon, it said, great, I connected to the target VM running on localhost 5005 over the socket transport. So now, my IntelliJ is running in debug mode, is now acting as a debugger for my web service. Now, for those of you who might not know or might have forgotten, what a debugger allows you to do is look at your source code and say, hey, listen, when my program that's being debugged hits a certain line of source code, stop and let me inspect what's going on with everything. Let me look at the value of variables. Let me, basically get in there, peek into the program. Let me root around to figure out what the values of certain things are, and then let me step through my code to figure out, what happens when certain lines of code are executed. The way you set a breakpoint in IntelliJ is that you click over here in the margin, and you'll get a red dot next to when you've got a piece of executable code on that line. So now, so this code isn't being executed right now. What's happening? My Jetty server, my web container, is just sitting there waiting for someone to talk to it. But now when someone does go and talk to it, so now when I reload my URL, IntelliJ comes to the foreground because the breakpoint's been hit in my doGet method. So what happened? What did I do? In my browser, I made the HTTP request. That HTTP request hit my Jetty, hit my web server. Jetty looked at the HTTP request, pulled it all apart, said, "Aha! You're hitting the airline application and the flight's URL. Send it to the servlet. And since you're doing a get, send it to doGet." So now let's take a look in the debugger at what is sent to this method. So doGet is provided two objects, an HTTP servlet request, a request object, and an HTTP servlet response. These are standard APIs with the servlet API, and these objects encode, or rather represent, the request and the response. So here in the debugger, actually, I'll try to make this a little bigger, maybe? How do I make that a little bigger? Probably need to make the whole thing a little bigger. I don't want to mess with anything. Hopefully you can see that okay. It'll definitely be there on the recording. I'm going to make this a little taller so it's more in the center of the screen. Here in the variables pane, you see all sorts of information about the variables that are in scope. So here you have these two parameters, request and response. Request, okay, the actual type of it is some internal to Jetty class. That's probably not so important. But look at all this information that you have. Okay, the original URL, the servlet path, a whole sorts of internal representations, things about cookies. I have no idea what. But one of the things that you can do under the debugger is that you can execute expressions, and you can basically evaluate code. You can run Java code. You can evaluate expressions in the context of the currently running method. So let's see here. If I then say evaluate expression, so this is option F8, I can type in an expression like request. Oops, I'll make it a little wider. I don't know why it's so narrow. You can say request dot, I don't know, get parameter map. And it's probably empty, right? Yeah, because there aren't any URL parameters. But I can say things like get method. Is it HTTP get? Okay, that's kind of neat. I can say I can get request URL. Here is like maybe kind of hard to read. It's the full URL that you got. So the whole idea is that that Jetty takes all this information about the HTTP request, puts it all in a Java object, and delivers it to your Java code. So now your code can go and work with this, and we'll see what it does in a little bit. Same thing with the response. So what does this code do? I'm going to step through the code. And so the way you step through the code is by, I guess there aren't ways here. Let's use these buttons down here. I'll show you what we can do. So there's step over, which is like I'm currently at an expression, an instruction. Execute that and then move to the next thing. So if I say step over, F8, that goes to the next line. And it just executed this thing called response.setContentType. Now the content type, okay. You guys know what MIME types are, right? You're dealing with data on the internet, whether it's attached to an email or the result of a URL. It's data. It's binary data, right? So if you're a consumer of that data, you want to know how that data is encoded. What the hell is all this? What do all these ones and zeros represent? That's what the MIME type is for. So the whole idea is that, the MIME type, or really in this case the content type, is for. So when you are fulfilling an HTTP request, one of the things you need to tell the requester is what type of data am I sending you, so that the requester knows how to interpret it. So here we're saying, oh yeah, this is text plain. You might want to return text XML. If you were generating images, it would be image slash JPEG or something like that. So the whole idea is that this is a way of telling the requester, hey, I just sent you all this data. Here's how to interpret that data. It's like, okay, great. This is XML. I know how to deal with that. Well, this is JPEG. I know how to render that. So that's what the content type is all about. So great. So now we're saying, hey, what I'm going to send you is some text. And you usually do this first, or you do it very early on before you actually write any content to it, because it's one of the first things to be sent back in the HTTP response. So when you do a GET, the semantics of this method is it will return, if there is no word parameter, it will return all of the entire contents of the dictionary, or it'll return the definition just for that word. And actually, let me show that to you first, and then we'll go through this. I'm going to stop debugging. I'm going to stop debugging by hitting the little red square, which is like, stop on a tape recorder. Does anybody even? It's like clicking the disk icon to save things, right? These kids today, they click on that. It's like, why does this mean save? What is that little square? It's like, well, it's a floppy disk, of course. And oh yeah, right. So anyway, so it's on your VCR, your DVD player, or your DVR or your streaming service, right? I'm sure there's something. There's this red button that means stop. So I'm going to stop debugging. Then I'm just going to interact with the application and not work with this. So I want to come back to this, but I want to put some data in there first to make it a little bit more interesting. And here's how I'm going to do that. If you just hit the top level URL, you get this page. Now, this page is an HTML page written in my best 1996 HTML. As you can see, it's very blocky, no colors or anything like that. And this allows you to interact with the web application using HTML forms, but it lets you hit stuff. So you click this submit button here, and this just hits the flight's URL that calls the GET. It also lets you it lets you post to that URL via this form right here. So doe is a deer. Click that. It posts to it. It sends an HTTP post, and we'll debug this in a little bit to create one. And now, if you go back in your browser, back to this page, and now if I list all of them, there's one word in the dictionary. Doe is a deer. We can then get the definition for a word like doe. What this does is it does a get of this URL. So the flight's URL with the query string word equals doe. Now let's go back to the debugger and see this stuff in action again. So I will reattach to the debugger. And now I'll go back here and I will I'll just list all the word definition pairs again. I'm back here at my debugger. Okay, I will step over this by hitting F8. And now I'm here. Okay, so the first thing that I'm going to do is I'm going to say, hey, was there a URL parameter with the named word there? And so I call this getParameter method. Now I'm going to use the step into command in the debugger, and what this will do is it'll step into the getParameter method. So here I am in getParameter. GetParameter is this helper method that does the following. It takes the request object and calls getParameter. So when I step over that, it assigns it says, okay, get the parameter with the name word. The value of that parameter is null, and that's true. If you look at the URL that I sent, there is no, we'll see in a second, that is just flights. There is no question mark after it. So the name parameter is null. So the word parameter is null. In this case, I'm just going to return the string null. Back here, up a method, and back in my doGet method, the word is null. So now I'm going to print, I'm going to call this write all dictionary entries method. I'm going to step into that. And now I'm going to write something to the HTTP response. I'm going to write out that text with all of the entries in it. Now, HTTP deals in text. And so in the Java API, in Java, how do you deal with text? How do you write text? Use a writer object, right. So the authors of the servlet API were like, you know what? We're doing a lot of I.O. here. Hey, let's leverage the standard APIs for Java I.O. So what you do in order to write stuff to the HTTP response is that you get a writer from it. And now you have a plain old Java I.O. print writer, probably like a lot of you used in your projects, in order to, that allows you to then write not to a file, not to a buffer memory, but instead write to the HTTP response. And this is really cool because now it's a standard API that you can work with. And so then there's this method called format dictionary entries. I guess I can step into that. You send it the dictionary of strings and a print writer. And so then it prints, it formats the word count and then loops over all of the entries in the dictionary and prints those to the print writer also. And, I suppose I should have done it while I was still doing that, but you can use the debugger then to see what is the key of the entry and what is the value of the entry. Which actually, maybe, no, I don't have that anymore. So I do have the dictionary right here, and it maps doe to a deer, just as we expect. Okay, so now I've written stuff to the print writer. The last thing that you do is you flush it to make sure that all of the data has gone fully to the destination. And then the final thing that you want to do in an HTTP response is set the status. So, right, you've all seen a 404 page. What does 404 mean? Why is it called a 404? Right, and what does that really mean? Yes. Well, you do get a response, but the response is like, you asked for something and it ain't here. So the HTTP standard defines not only a data format for transmission, but it also defines a whole series of different response codes. A lot of them are error codes, right? So like the whole 400 series is like, hey, you asked for something and I couldn't give it to you because it didn't exist, or you didn't have permission, or it's moved someplace else, all those kinds of things, right? The 500 series is like something went wrong on the back end, right? So you've probably seen like a 500 error. And that means like internal server error, right? So that means that, oh wow, look, your code is broken. So like, for instance, if you get a null pointer exception someplace, you'll want to return a 500. If the user asks for something that doesn't exist, you'll want to return a 400. Everything is hunky-dory if the response was, if the request was handled successfully. What series of return codes do you use? 200, right, great, you guys know all this. Now, so the last thing that you do in your method when you handle when you handle a request and produce a response is set the status. And set status takes I think it's an integer. Yep, an integer, and there are all these constants in the HTTP servlet response class, SC for status code, I guess. They have all these static fields. Actually, can we see it right here? Oh yeah, a whole bunch of them here for every HTTP status code, so that you can have something more readable than just 200. Right? There are all these constants that allow you in your code to just say, okay, great, this is a response code of 200. So 200 means good. Yay! Okay, everything worked because you handled it successfully. And now you're done with your do get. So what I'm going to do is I'm going to continue, resume program, I guess is what they call it here, F9. And so sure enough, the data that I wrote to that print writer that came from my servlet response got sent back to the web browser. So that's the life cycle of an HTTP request. You get the request, you handle it, you do something with it, and you send it back to the server. So that's a get. Let's go back to our go back to this again. Now I want to show you, I'm going to go a little faster now, but now I'm going to walk through what the doPost does. Now doPost is invoked when, when you submit this form. So Ray, a drop of golden sun. I click submit here, and this calls doPost. So it sends an HTTP request. If you go and look at the spec, or you look at what goes over the wire, the HTTP request includes like these headers about here's the URL that I want. Here is the verb, the method, the HTTP method that you're invoking, and here's post. When Jetty sees that come in over the wire, it's like, oh, okay, great. Here's the URL. I'll go find the servlet for that handles that URL, and oh, look, it's a post. Okay, I'll call doPost. You get a servlet request and a servlet response just like before. But now we're going to implement different logic because it's a different verb that is being sent to the HTTP server. So again, we're going to return plain text. Now we're going to say, okay, is there a word request? If there's not, then we're going to issue an error, and I'll find a way to do that later. Otherwise, there's a parameter for request. There's a parameter for the word. There's also a parameter for the definition. Go and put it into the dictionary. So in this case here, the word is Ray, and the definition is a drop of golden sun. Put that in the dictionary. Now the dictionary, I guess I really didn't talk about this. The dictionary is just a hash map that's here in my servlet object, right? So this is that in-memory storage that I was talking about. And remember, because the Jetty server is still running, this sticks around through multiple requests, right? So your Jetty server, I go back to my shell, it's just hanging out. It's just sitting there. I'm waiting for requests. I'm just sitting here. And so then it's persistent over multiple requests. So unlike your command line program that starts up and shuts down, nope, this thing stays around for a long time. This thing stays around until you stop it or it crashes. So back to where I was down here. So I put the words in the dictionary, and now I'm going to write out the definition there, which is what I'm going to do. Write that out to the response. Everything's okay. And I'll continue on. And now here, I've defined Ray as a drop of golden sun. So this is how, right, this is a little different, right? Now instead of just having this command line program, you're hitting things in a web browser. And you're interacting with your code through a web browser. Any questions on that? Okay. Let's take a little break. I'm kind of parched. I need something to drink. We will then we're going to come back, and I'm going to show you how to unit test your servlet. Yeah.
How do we stop the data?
Control C.
Oh.
Yeah. As a matter of fact, and I'll stop. Sure, I'll stop mine, and I'll leave it up. Whatever. Okay. Awesome. Let's take 10 minutes. We'll be back at 6:50, 6:55.